All right, this is 2.2, day 1 of polynomials of higher degree. What we focused on in trimester 1 is on linear functions, degree of 1. Then yesterday and Friday we focused on degree of 2, quadratics. So just a little warm up in your head. Think about what would be the shape of these 4 functions. What would be the shape of the graph? No need to write it down. Just look at the blue, the green, the red, and the purple, and see if you can think of what would be the degree or the shape of those graphs. Okay, who can tell me what the degree is and shape of question A? What would be the shape of that graph? Guess right there. A line. That's a linear function. The degree is 1. Who can tell me what B is? Share part B. A parabola, because its degree is 2, a quadratic. Thank you. What about question C? Yes?
Cubic.
A cubic. A snake. And our last one, D. Anyone besides Brandon? Oh, Brandon. Kate. I don't know. Question D. What would be the shape there? Talked about them a little bit in algebra. Degree is 4. So we have lines, we have parabola, we have snakes. What was the next one in algebra 2? Brandon? M or W. Yes. So we're going to focus on today is questions C and D. Being able to graph these functions, identifying their end behavior, and finding their x-intercepts. And then tomorrow we're going to continue this lesson and be able to graph them without graphing calculators, because our next quiz next week is where you are not allowed to use a graphing calculator, because we know we can enter all this into our calculator and graph it very quickly. So we're going to give you some tools today to start to pick out some important pieces of the graph. Okay, let's move on. This first slide, I don't want you to write anything down, just kind of warming you up to reviewing what is a polynomial. We talk a lot about polynomials in Algebra 2, so this probably looks familiar to you. It's got a lot of stuff in it. The important 2 pieces is the a sub n. That is called the leading coefficient. And then the n right here is called the degree. The leading coefficient helps us to identify what is the end behavior. Maybe it rises here and falls over there. Or maybe it rises and it rises. It tells us where the end behaviors are. Also, the degree helps with that. So if I think about an x squared degree, so degree of 2, think about the quadratics. Our end behaviors were either rise and rise or fall and fall. So think back to what we did the last couple days. So we're going to just answer to our class. In the first example here, moving it down a little bit, push that screen recording off. The first function, what is the leading coefficient of this first function? What's the leading coefficient? Someone to share with me. -2. What's the degree of, or the leading coefficient of that one? 1. So if there's not a number there, then it's 1. And what's the leading coefficient of the last one? We call that kind of a constant. It doesn't have a variable x. That is 14. Okay. Now let's get into the degree part. In the first polynomial, the degree is what? 5. We haven't talked about the degree of 5 yet. We talked about it in Algebra 2 a little bit. What is the shape of a degree of 5? We call those quintic graphs. Quintics. Kind of like an M or W, but it's more of, it starts to mirror the snakes. So the degree is 5, and we're going to get more into advanced. And then the second example there, the degree is 3. So we talked about that one on the previous slide. What is the shape of degree of 3? Degree is 3, so it is a snake. Good job. A little tricky, this last one. What's the degree of the last example? 1. Anyone, give me a thumbs up if you agree the degree is 1. Give me a thumbs down if the degree is something else. If you disagree, tell me what you think the degree is. If you gave me a thumbs down. No one disagrees? A little scared? The degree is actually 0. The reason why it's 0 is because we don't have an x. We don't have that variable raised to the first power. It's still a line, but the degree is 0. It's just a constant, goes across at 14. Okay. We're going to do some examples with leading coefficient test. This slide is just kind of reviewing what are polynomials and what do we need to have in a polynomial. This first example is my function. Its shape is a snake. It's continuous, it's smooth, it is a polynomial. Let's look at this one, the second example. What's wrong with that graph? What's wrong with it? Why can't it be a polynomial? Nope, you don't have to write it down yet. I'll kind of warn you where I want you to write. It breaks off. It has a hole. We call those holes in the graph where it kind of stops and it starts up again. So this is an example of not a polynomial, and we're going to focus on ones that are in our homework.
Is a step function polynomial?
A step function is not a polynomial. Remember that ladder that we talked about in last chapter? That's not a polynomial. The last example. There's a couple issues with the graph. It has kind of like some jagged edges. That also is not a polynomial. So for you to have a polynomial, you have to have a continuous line or curve, and it must be a smooth curve. All right. We're going to lead to this. Last example set, and then I'm going to have you do some writing. Power functions. This is what we're getting to now. We're getting to third degree, fourth degree, fifth degree. What happens after third degree, so think about the odd functions. Right here, x to the third, x to the fifth, so we call these cubics and snakes. Do you remember these from Algebra 2? They just kind of start to mirror each other. Every time we go up in an odd function, we're going to still get that snake. In our even functions, those are like what we talked about the last 2 days, the quadratics, or now fourth powers. Some of you said the word m or w. In Algebra 2, we call that a w, where it kind of has a little bump, then it goes on. That can happen. We're rising on the right, rising on the left. What if it was x to the sixth power? Does the same thing. Maybe it falls and falls, and it can do that. And that's what this slide is saying. Okay, this is what I do want you to write down. We introduced this in Algebra 2. It's called the leading coefficient test. It's starting to tell us what is the graph going to look like in its end behavior. So I do want you to write this down in your notes, a little chart. So we talked about the leading coefficient. Remember, it's in standard form. It's the first term. It's the coefficient in front. We're looking at two things, the degree and the leading coefficient. So the top two boxes are when the degree is odd. So if we think about odd functions, we're talking x to the third, x to the fifth. If you want to add that to your box, you can remember that's totally fine. Then the left box is saying a sub n. So the leading coefficient is greater than 0. So what's greater than 0 are positive numbers. So our leading coefficient has to be positive. On this box on the right, a sub n is less than 0, so things leading coefficients that are negative numbers. And then what's in the black on those two boxes is what the end behavior is. So I'm just going to draw a quick sketch so you can visualize them in your head. And we'll do that in green. So my degree is odd. My leading coefficient is positive. So what will happen on the left-hand side of the graph, so over here, it's going to fall on the left, and then it's going to rise on the right. So think about in the 70s, Staying Alive. It's going to go like this or like that. Do you remember that? Have you seen the movies? I was a little still too young to dance, you know, in Staying Alive, but I won't tell you my exact age. So falling this way, rising this way, and then something kind of happens in between those two end behaviors. Maybe kind of goes up, and then it comes back down. Something's happening between those end behaviors. And we're going to find out what the stuff in between is later on in our lesson. So now this one, where our degree is odd, and our leading coefficient is negative, we are going to rise on the left and fall on the right. And then something happens in between there. So rise on the left, fall on the right, and then something happens in between there. So I'm just going to connect them. That's the top two boxes. The bottom two boxes, we're changing it up. Now our degree is even. So think about those parabolas that we talked about the last 2 days, the x squareds. They either went like this, or they went like that, down, up or down. And that's dependent, up or down, on the leading coefficient. We have x squared, x to the fourth, x to the sixth, x to the eighth. Most popular ones, we stay within x squared, x fourth, x to the sixth, about the highest we ever go in our class. Again, the first box, like above, the leading coefficient is greater than 0. So it is a positive number. And then this one is a negative number. So what this bottom box is saying, it's going to rise on the left, and it's going to rise on the right. So if we're talking a quadratic, it might look like this, or rising here and rising here, we might have like a little W, a little curve in the graph. Okay, I'll move this up a little bit now. You're probably done with those top boxes. The last box, the degree is even again, so those parabolas, or W's and M's, and which one will it be now? Will it be the W? No, you're shaking your head. Why, Skylar? It's less than 0. So what is it going to look like? It'll go down. So it's going to fall on the left. It's going to fall on the right. And then something happens in between those end behaviors. Maybe it goes, oh, thank you. I'll stop it here in just a second. So it looks, we call it an M. And my 3-year-old, we're working on her letters. She looks at the letter M and she just calls it McDonald's. Yes.
So what happens in a polar plot then? Is that?
And what?
In a polar plot?
Like cosine and things.
Yeah.
That I don't know offhand.
I think it's.
Oh, you're trying to take